We're going to start in just a minute, so let me just say good morning or afternoon to all of you in attendance. Thank you so much for joining us for today's webinar called "Is It Safe to Inhale in an Office Building?" I have a few administrative announcements, and I'm just going to check our activity in a minute. Today's session is being recorded. The recording will be forwarded to all attendees after our session. At the end of our session today, our speaker's slide deck will be attached in the chat section. That will be at the end of the session today. All of your lines are muted. However, you'll notice the Q&A tab. If you've got a question, please post it there. We'll try to leave around 15 to 20 minutes to address your questions. For those of you with questions or requests needing more attention, you'll find our panelists' contact info in the chat section. So panelists, if you haven't posted in the chat section, please do so. All of our speakers are working from San Francisco, or at least that's where our offices are located. And if you just give us one more minute to give everyone a chance to log on, and we will go ahead and get started. So just stand by with us for a minute. There's already a question in the Q&A, and the answer is yes. That's my backyard in the background. It's just one of my favorite parks. What can I say? It's and no, that is not the Stanford campus. Just a quick couple of housekeeping reminders. So do use the Q&A tab. We are going to be getting to your questions toward the end. I just want to thank our panelists, and I'm going to make a couple of quick introductions here. But so my name is Dan Mihalovich. I am the founder and CEO of GRITIG, which is headquartered in San Francisco. We are as our screenshot tells you there, we're an office leasing deal-making software platform. And I'm going to tell you a quick word or two about that, and then I'm going to introduce our moderator, who's Ned Fenney from Fenney & Mel Architects. GRITIG is as I say, a software program that was born out of necessity. I have a background in 30 years in the office leasing brokerage business, and it's my opinion that anyone or everyone who's ever touched an office leasing deal has the scars to prove it. So it was our time to modernize the leasing process, and the core concept behind GRITIG is to essentially make real estate, the leasing transactions more transparent. So moving commercial real estate transactions to a more transparent and open platform allows for deals to happen a lot faster and more efficiently, and that means that stakeholders, that's anyone who is involved, all the decision makers, stay in the loop every step of the way. So the GRITIG platform allows all parties to consummate deals much faster and without surprises. So our industry, love it as we do, maintains a well-deserved reputation as a dinosaur industry. So transparency has been in short supply in the office leasing process, with virtually every other industry evolving and benefiting by adopting collaborative shared processes. So GRITIG is a public marketplace versus other domains that require or that remain inaccessible except for paying subscribers. There's no software to download. Just log in and try it. So that's about all I want to tell you right now about GRITIG. Available later for questions if you have them about GRITIG. So let me introduce you to our moderator from Fenney & Mel Architects. If you give me a quick moment here. So Ned Fenney is the co-founder and president of Fenney Mel Architects. He has 40 years of experience in the commercial sector, large building renovations, seismic upgrades, and they have massive experience with tenant improvement interior design. Ned is the current vice chair of the Code Advisory Committee to the San Francisco Building Inspection Commission. If you received today's invitation from Grittig, you'll recall the COVID compliant space plan we included, which is drafted by Fenney and Mel. So let me just add a quick, this is something I learned from my parents and you probably from yours. Where there's a will, there's a way, and today we're going to help everyone to see the most safe and intelligent way forward as we answer this question. Is it safe to inhale in an office building? I'm going to turn it over now to Ned Fenney.
So thanks, Dan, and I appreciate Grittig and also my colleagues Tunde and Ashwin for participating in this webinar today. This is a really important part of the post-COVID reoccupancy program for a lot of landlords and a lot of tenants, so it's really timely. Our firm, as Dan mentioned, we are in a unique position in the marketplace because we work with both landlords and tenants. We design spaces and we also renovate buildings. So we understand the unique perspectives of both sides of the leasing transaction and how to make buildings safe. I wanted to, we're going to get into a lot of detail and a lot of specifics about systems. One, I want to encourage people to ask questions if there are terms or whatever that you don't understand, and I'll help to get those explained. But I also want people to focus on 3 or 4 core concepts or themes for today. The first concept that is really important to understand is that there is no zero risk. There is basically a risk reduction process here. And then there's also the level of communication between both sides of, well, not only the landlords to tenants, but also tenants to their staff and staff to their customers as well, in a certain amount of transparency so that information can flow between the parties and then people can actually then make decisions about their relative risk. The other part to this, the theme that I want you to focus on, is the idea of building trust. So in order to build trust between all the different people who are affected by buildings and their systems, there has to be a level of transparency so that tenants can understand how landlords are running their buildings and what measures they're taking to help ensure the safety of the occupants. And the other part to this that is very timely is that tenants are now changing their focus. They're now focusing on their health, the health of their employees, the health of their customers, and how the building that they occupy in affects their health. So whereas a few years ago that might have not been on the top of their agenda, it certainly is on the top of their agenda today. One of an important person that has been focused on this for many years is a gentleman by the name of Joseph Allen. Joseph Allen is an assistant professor of exposure and assessment science at Harvard's T.H. Chan School of Public Health and a director of the school's Healthy Buildings program. Early on in the pandemic, he wrote a paper on 5 areas to mitigate risk in office buildings. And his approach is a tiered approach. So the first measures have the biggest influence and so forth down the list. His 5 tiers are hazard elimination. Keep the high-risk folks at home. In other words, people who are at very high-risk levels shouldn't be in small enclosed spaces, and we now know that to be true, and especially in offices. And that not only in offices and in buildings, but also in spaces within the offices. The second tier is bring in the essential personnel first. So obviously keep your offices running, your buildings running, bring in the essential people first. The third level is optimizing the engineering systems and controls to limit the spread. And that's what we're talking about today. Also, the next level is de-densify the buildings. We've heard that as well, fewer people. And I think Dan can bring up the floor plan and that illustrates that as well. And then finally is using personal protective equipment, masking that is now front and center in all the news and helping to spread the contagion. I'll post a link to an article where he goes into detail about this if you're interested in reading it. I'll put it in the chat channel. So our firm has been working on over the last few months, looking at different plans in office buildings to help focus on dedensification, where we're doing analysis of if people come back into the office, how many people can safely come back, to help with not only figuring out seating arrangements, but also on shift management. We're also doing, looking at support spaces to support the sanitization and hygiene for the additional methods to keep surfaces and touch points clean. And then we're also focusing on creating signage and wayfinding to help folks understand how to behave in different spaces within the buildings, and also how to circulate safely within the building. And then finally, looking at different detailing about how to install more touchless access points in the building. In the plan here that Dan has on the screen, it's a hypothetical plan that we looked at about how to adjust the seating areas and circulation patterns so that a safer office environment could be occupied. You'll notice the distance between the folks seating in the open office areas. I'm not sure you can see my cursor, but and also in the blue areas of the conference rooms, you can see where the seating is spaced out per the COVID-19 recommendations from the CDC of the 6-foot spacing. So there's so much you can do from a spatial standpoint, an architectural standpoint. And then once again, today's discussion is really about how to run the air systems in the building to support that spacing. So at this point, I'll turn it over to Dan and my colleagues. And then if you post questions in the chat channel, then I will help moderate the questions after the presentation.
Thank you very much, Ned. So let me give a quick introduction to our speakers today. And again, this is to me, and I've been in the office leasing business for, I just sort of round now to 30 years. This is sort of the elephant in the room for me in this pandemic. And that is with all of these safe spacing measures and et cetera that Ned just addressed, is it safe for us to ride in elevators and to sit in an office floor for 8 hours a day? So we went to an expert in the field, and those are Tunde Muntz and Ashwin Pandit from the firm Gutman and Blavoet. I want to pronounce it the French way, even though je ne parle pas français. So let me just say, Tunde is a principal of the firm. The firm has been established in San Francisco in 1956. Their entire focus, or their main focus, is high performance building design. Tunde is a licensed mechanical professional engineer with over 30 years of experience, building out over 1.5 million square feet of space. And I want to emphasize her and their expertise in developing HVAC systems for very high-end projects like hospitals, medical centers, not just office buildings. And one of the questions we're going to try to answer today is, if office buildings had as safe an HVAC environment as hospitals, would that be okay? But Tunde has been involved in over 90 healthcare projects. Ashwin is also a licensed mechanical professional engineer with a master's in mechanical engineering. He's been with the firm for 4 years, and this is the brain box of talent we have today to help us all to understand these air quality issues. So I want to turn this over now to Tunde and Ashwin. They've got some slides to share with you, and please take it away. Thank you so much.
Thank you, Dan. Thank you for everyone joining us to this presentation. My name again is Tinde Muntz, and Ashwin and I work for Goodman and Blavoet, and our main business, core business, is design of building systems. And I'm a mechanical engineer as well as Ashwin. We design heating, ventilating, air conditioning systems. Shortly, we call them HVAC systems to speak faster. And for healthcare, civic, and office buildings. We will talk about our agenda will comprise of a contemporary description of the HVAC systems, the psychological effects of COVID-19 on occupants, and strategies and mitigation measures. We will tell you what available equipment is currently on the market, used in healthcare or higher strictness type of buildings that can migrate towards office buildings. We will talk about consequences of these mitigation measures on operation and cost for landlords. And we will end with specific guidelines for landlords and tenants. We are here to shed some light about how we can prepare the office environment for being used by companies returning to business. And from here, please, Ashwin, take it on.
Thank you, Tunde. Good morning, everyone. Thank you for taking the time to join us today. I hope you're all doing well, and it's a pleasure to present to you today. So I'm going to start with what most current buildings have equipment installed in terms of HVAC. So here is a quick overview of existing equipment for an office building. This is a description of an office building. We have an air handler system in most cases here that's going to be recirculating. We're going to discuss that in further detail of what the risks and the mitigation measures are. And we'll also focus on occupancy level airflow. That is a situation that we need to focus on because a lot of factors play a role there, which will also depend on occupancy interaction. These systems are usually called central air handling systems or HVAC systems, short for heating, ventilation, and air conditioning. This is a typical terminal supply area of conditioned air from air handling systems. As you can see, there's a big question or debate these days of how spaces are going to be arranged from here on. Are collaborative spaces going away, for example? Here, for example, we have people seated in an office space. You can see how close they are and how interactions can affect each other in a COVID pandemic era. There are lots of guidelines coming down from the experts in keeping distances and using plexiglass. We'll focus here more on how the airflow and how interaction between people affect this dynamic. The facts on COVID-19 or the research per se on COVID-19 is changing every day. So this causes a lot of questions and doubts when implementing solutions or taking a stand, for example. Every day we find new information and we want to find a way to deal with this. So we want to start with, for example, let's consider COVID-19 as in a worst case scenario being completely airborne. In a situation like that, there's a chance that it could enter through the air handling system and cause spread. We're going to prove that that is highly unlikely in a central air handling system, and that the focus should be at the occupant level. This is a study that took place in South Korea recently. It shows how COVID-19 spread through the office on a single floor. Now, this could be from different factors could affect this. It could be the central air handling system. It could be the interaction between people. But however, this was early stages during the COVID-19 pandemic, and a lot have been learned from this situation. Next, we know that from contact tracing studies that exposure to the amount of virus that infects a person is very time dependent and depends on exposure. That's why it's well known that frontline workers and essential workers need to have the best PPE equipment to protect themselves. This is a quick breakdown on how everyday human activities can cause spread. COVID-19 is known to spread through droplets that are liberated through human activity. For example, cough, a sneeze, and even breathing, for example, can be dangerous. That's why it's really important for everyone to follow guidelines issued by the CDC and wear a mask. It is known that there are different studies that suggest the amount of asymptomatic people in the population is between 20 and 80% in some cases. For this reason, it's important to take a stand and follow all guidelines at the occupancy level. Dr. William Bamflett, a pioneer in our industry and the president of ASHRAE, which is short for American Society of Heating, Refrigeration, and Air Conditioning Engineers, has done a deep study and has reported that there is no suggestions to say that central air handling systems or HVAC systems can cause virus spread from space to space. However, we feel that that statement is highly dependent on how well the current systems are, the conditions of the current systems are, whether they're constantly maintained or serviced in time, and if they have the latest filters that are being implemented. Also, this statement above only addresses virus spread at the air handling level, whether it's spreading from one space to another. It does not address what's happening at the local level, or we call it airflow dynamics at the local level. With that, we come to strategies and mitigation measures. I'm going to hand this over to my principal, Tunde.
Thank you, Ashwin. I will address strategies and mitigation measures. So we were talking that we are here to talk how to decrease risk in the indoor environment of an office building. The first measure that we recommend is enhanced filtration. A normal standard pre-COVID-19 era was to have a 65% efficiency filter. The efficiency is relating to number of particles and size of particles stopped at a filtration in a central air conditioning unit that Ashwin was mentioning. Hospitals have 95% filtration for general patient area throughout the building, while very critical spaces like surgery rooms for cardio or ortho, they have much higher filtration type, like 99.999% efficient. So filtration level varies depending on the risk that we try to mitigate and activities in the space or who we are protecting. Another measure is using UV lighting. UV lighting has the property of attacking live bacteria and viruses and decompose them to harmless particles. Local exhaust for source control is used in spaces where we want to, we know that there is high risk, unknown people like waiting rooms or reception rooms. We do not want that air to be recirculated by the air handling unit, And those spaces, we recommend to have them exhausted with an exhaust fan directly to outdoors. At local level, in rooms that we try to improve the environment, we recommend portable freestanding high efficiency particulate air filters that I mentioned earlier. They are usually, the equipment is called air purifiers. So they are only affecting one room in which they are placed. Another measure that has been discussed a lot is the control of temperature and humidity. There are people that are asking, should we air condition the space? Is it safe or is it helpful? Definitely air conditioning should be used in occupied spaces. The humidity in normal occupied spaces is maintained below 50% relative humidity, and in summertime that is very useful. In winter time, when mostly the spaces are heated, the humidity goes lower than 50%, all the way down to maybe 20 or even below 20%. From articles and studies done, there is knowledge that human air pathways are better equipped to defend themselves by having a humid air that is inhaled rather than dry air. Humidity control comes in expensive. Hospitals do have systems that control humidity to keep them constant around 50%, between 40 and 50%, but it hasn't been installed in office buildings as a standard. Next. Another measure that it's only familiar for healthcare buildings is to keep high density and high risk spaces at a so-called negative pressure. The negative pressure is obtained by exhausting more air than it's supplied, thus inducing air from clean spaces into this high risk space. So creating like a suction phenomena at doors and openings towards this high risk space. This can be obtained by using the HVAC system, and it is obtained by balancing the supply and the amount of air that's removed from the space with high risk. Again, the UVGI equipment is another measure that can be installed in equipment and clean up the airstream. Outdoor air. Psychologically, everyone would like to have fresh air all the time from the space, for the space that they live in. A hospital in New York, the demand of the healthcare providers was to have the entire hospital turn to 100% fresh air. It is both psychological, but it also has its merits, but it comes with a cost. It costs more energy to condition, and it is not all the existing equipment is capable of doing that. What we can do is increase the rate of the percentage of outdoor air to the occupied space. We do not recommend to increase the total amount of air that circulates to the room, because that induces currents and will mix the viruses more throughout the room. So we want to highlight, we want to emphasize that we want to increase the outdoor air rate, but not the total air quantity inside an occupied space. Another measure is to provide during occupancy, during periods of high occupancy, to provide a flush of the room, the HVAC system to turn over the air several times, thus filtrating the air at the central unit system. So before new occupants come in, we recommend to increase the ventilation while the room is not occupied. Next. For the, everything that I touched upon was regarding existing buildings. For new buildings that maybe landlords are thinking of building, the best solution would be to use 100% outside air units that have the benefit of being very flexible, provide fresh air to all spaces all the time. The downside for this is that it would increase energy consumption. So we recommend that if 100% outside air is designed for the building, an energy recovery system is associated with this to lower the energy costs. This slide is touching upon filtration. So this equipment that is normally either in an air purifier or in the air handling unit retains particles, and their efficiency depends, that their construction and density of their material that holds the particles that are in the air, that circulates through them. A MER 14 is the rating for a filter for hospitals, for all the areas that I was talking about, but not for surgeries or more critical spaces. As you can see, if COVID-19 is associated as to be an aerosol, it has a 0.3 micron in size, and a filter of MER 14 has the capability to stop 80% of the smaller particles. There are filters that are very specialized, and they do cover the smaller particles, and they stop viruses. They are manufactured, but they are used for military situations, or pharma, or very critical food preparation situations. So I just want to mention there are so-called ULPA filters that ensure that particles of very small size are stopped. Of course, not 100%, but in very high quantity. And they are not used in, their prevalence in use is not there because they increase the energy use for the HVAC equipment because they require more energy to push the air through them. This is an example of where the UV lights are installed in air handlers. They are installed for hospitals in front of the cooling coil to maintain the coil clean of bacteria, viruses, and fungi, since the cooling coils tend to be very humid due to condensation of water on them. The UV lights can also be used inside ducts to kill the viruses in the airstream. To be effective, the airstream has to travel at a low velocity to have more time to expose the viruses to the UV light effects. To give it over to Ashwin to talk about this new technology.
It is important to note that the use of high efficiency filters and also the use of UV light at the air handling level can bring down the spread of virus via the air handling unit next to close to 0%. Our main focus should also lie in the occupied spaces. This is a nice product by Indigo Clean. These are products that use visible light spectrum and also UV light spectrum to disinfect a space. They are commonly used in hospitals and clean rooms. We encourage the usage of these products in everyday activities or high density spaces going forward. UV light is known to kill COVID-19 virus.
Another technology that is out there, but it is not used currently in buildings for offices, is the plasma air purifier. The phenomenon used here is what happens naturally in the natural environment. High ionized particles are created by sparks, cold sparks, and they have the property of attaching themselves to bacteria and viruses and break down their structure to harmless components. The particles that are broken down are captured by a filter. As you can see, they are used for tuberculosis, MRSA, E. coli, Legionella, and they have a very high kill rate. This technology is available out there for use. It's not only for the industrial level. For example, there are mobile units for portable, and air purifiers can be used in spaces of different size. They are quite costly, so they are currently used in medical office building, dental offices, and medical office buildings that are not in a hospital. Some guidelines. We were trying to brainstorm type of questions that the landlords will be exposed to from their tenants. Questions like, is the HVAC system a source of infections? We can say that they are not if all the equipment is in good order, and there is no study or nothing to show that HVAC system is a source of infection. Another question that might be landlords can encounter is, can HVAC systems improvements guarantee tenant protection? As we talked before, HVAC addresses risk. It lowers the risk and controls somewhat the infectious particles path. There are two parts. It's through the air handler equipment, and also through pressure pressure control of rooms. So if you have a room that is exposed, it's high risk of having viruses, you can you can try to contain those only in one room by keeping it at negative pressure. We encourage the landlords to describe the improvements that they made to the HVAC system to address concerns from the tenants. And also there is the question about liability. Can the landlord guarantee that there will be no infections in the building? And I will let Dan touch more upon that, but there is nothing guaranteed by the HVAC systems, since it is a lot dependent on the occupant's behavior at the room level. Advice for the landlords beyond the ones that we mentioned would be to implement a low cost and high return HVAC improvements that are easily done. And of course, they have to maintain their filter condition regularly. They have, depending on usage, and if it is a high occupancy space, we recommend to change the filters more often than normally advised by the mechanical engineers.
As much as we want to stress the importance of the landlord's role in keeping the building infrastructure well maintained and serviced, we want to encourage the tenants to also play an important role, to stay informed, to begin a conversation or stay engaged. For example, getting a description of the HVAC system from the landlord, understanding how the systems work or where they are located is an important factor in keeping the spread to a minimum. Recommend actions. The role of the tenant in engaging with the landlord is an important one. We encourage them to negotiate with the landlord to provide local equipment that reduce infection spread. Ask for what type of improvements the landlord has implemented in their buildings in a variety of spaces that can range from restrooms to private offices and open offices. So with that, we end with references and we are open to questions.
So we have a couple questions about elevators, but before I go into the details on that, I just wanted to reiterate the transparency that I talked about earlier. You know, reoccupancy is about building trust, and it's not about what parties have to do, it's about what the different parties in an office development need to do to build trust. So giving out information, accurate information about how systems are designed and how they are run will help everyone develop a level of trust that people are operating the buildings in the safest way possible, and that they can then make their own decisions about their own personal risk. So different companies have different tolerances about risk, about who their customers are, who their staff are, and so forth. So they need to have accurate information about how the building is being operated so that they can make their own personal risk assessment. And in that regard, a couple questions have come up about how our elevators, how to mitigate the risk in elevators. And 2 points that I'd like Ashwin or Tunde to address is the air exchange rates in elevators, and then the possibility and efficacy of using ultraviolet or lighting systems to cleanse or purify the elevators between uses.
I will take that question. Thank you for the question. Elevators are not air conditioned by the mechanical or by the building systems. Elevators are an equipment under a special code, and only the elevator manufacturer provides equipment that services the elevator. They have little fans, I think. I'm not familiar exactly with how much ventilation they allow, but being into a shaft that has very little air, I can say that there is not a good ventilated space. Definitely UV lighting or purifiers would help. Tell you the truth, I walk in the buildings now and I take the stairs. It's too close. It's too small of an environment, and you never know if somebody comes in without a mask. So I prefer to take the stairs.
Thank you. Another question that is out there is, how would you recommend that office leasing brokers that represent tenants propose that these measures are instituted? There are costs, obviously, and does that mean that, and perhaps this is a question that Dan can answer, does that become a base year increase in expenses?
If you'd like me to go first, Tunde.
Sure.
Sure. I think you know, we've been through a variety of cycles. When I think back to 9/11, for example, when building security costs just you know, soared, and how those costs were handled by building owners. So I think generally speaking, and let's just acknowledge that there are some very capable real estate lawyers that are on this call. I think building owners will be as creative as they feel they can and pass through what they're able to. But you know, long-term capital expenses, as you're improving infrastructure of the buildings with HVAC systems, that those should not be pass-through expenses beyond what is normally allowed using the standard accounting principles for passing through long-term capital improvements. But you know, this is just going to be a negotiable item that's going to have to be addressed, you know, lease by lease. And you know, as a broker, all I can recommend is what I've recommended to clients since the beginning of time, which is to surround yourselves with the appropriate experts that can address any and all of these types of questions as you proceed forward in any lease. So, yeah.
Another question, excuse me, is what range do most office HVAC systems use for outside air? Tunde, could you or Ashwin answer that?
I'd like to touch upon this. So usually, depending on the jurisdiction, office buildings get about 20 to 30% of outside air ventilated.
Okay. And then there's a question about clarifying which of the systems that you guys recommended would be centrally installed, probably a landlord, and which of those pieces would be locally installed, likely a tenant installation.
So centrally, go ahead, Tundi.
Go ahead, Ashwin, please.
Yeah, so centrally we could use the high efficiency filters that Tunde touched upon, and also the use of UV light at the air handling system itself. That'll ensure that the disease spread is kept to an absolute minimum when it comes to space-to-space transmission. Whereas at the local level, we could use a variety of factors of using local air purifiers with ionization technology, local filters like the HEPA filters, and that's a more expensive option, I have to add, and also the use of UV light. Now, there's more studies going on in that subject of UV light and visible light. There are products out there that say UV light could be damaging to human tissue. So depending on the product and depending on the study, UV light can be used safely in unoccupied spaces. When the space is not occupied, the occupancy sensors could turn on the UV system and disinfect the space. Whereas the product that we just went through, the indigo lights, claim that they have a product that doesn't have any effect to human tissue. So there are lots of variety of products out there that can be used at the local level.
So just to add a layer to that, we had a question about elevators. Is it possible that we might see building owners installing UV systems in building elevators and also in restrooms throughout the building?
Correct. Yes. Yeah.
That's an excellent question, because I think elevators would be ideal for using UV lights. When the elevator is not occupied, it can turn on through occupancy sensors or light sensors. And in restrooms are already some spaces that are using UV lights in, for example, hospitals and clean environments.
Okay. There's a question on open plenum buildings, and then another question about whether or not adding fans or UV systems to an open plenum building or within the space. So the question is there more risk in an open plenum building, meaning there's no, I believe, no lay-in ceiling, and you're running air throughout the entire volume between the two structural decks?
I think the open space, so there are two different things: plenum or open space. So without a ceiling. Without a ceiling, the volume is larger, and usually the diffusers that supply the air for spaces without a ceiling create more currents inside the room, because a ceiling has an effect of doing the air flow is doing the mixing up at a high ceiling level. If it is no ceiling, the ceiling effect goes away. So in my opinion, buildings that have no ceilings are a little bit more trickier, and I think more exposed to risk.
So the follow-on question then is, if it's an open plenum space, does it make sense to add additional fan or air moving devices and or UV devices in those spaces?
Yes, if I understand the question correctly, the question is asking if adding more fans or fan core units, it depends how they are added. So if we put in fans that recirculate the air to pass the air through filters, through HEPA filters, they'll have to be done carefully, so the air that is moved by these fan core units do not increase turbulence inside the room and spread the virus throughout the entire space much faster. The UV lights, definitely, they are a good addition. They do not affect the currents, air currents in the movement and movement of the viruses. They would be attacked at the place where they occur. So that's my...
Okay, a similar question is, for buildings that don't have a central air system and are naturally ventilated, like a lot of older buildings in San Francisco and other cities, is it a good idea to use local filters and or opening windows and or adding fans to the space?
Let me just interject 1 second. I know there are several other questions, and if our panelists can hang around, I'd like to keep the conversation going long enough to address the questions. And of course, the folks who are attending can always reach back to our speakers to ask questions privately. But let's keep going and try to click through these questions. I think everyone can see the questions that are in the queue. But please go on.
Naturally ventilate all spaces that do not have mechanical ventilation. They have, I'm sorry to say it, but a poor air circulation, and it depends how large the room it is. Actually, the code eliminated natural ventilation from the buildings totally. Before 2019, the codes allowed natural ventilation for rooms not deeper than 10 feet or 12 feet, something like that. Definitely, it's better to open the windows than not having them open, but that cannot be done all the time due to weather conditions outdoors. We recommend air purifiers and introducing fresh air mechanically constantly. And so basically add add ventilation using mechanical means.
Got it. There was a question about code requirements coming down the pike, and as an overarching process, the way codes are developed in the United States, typically there is a model code developed by an association of code researchers, and usually it's approved by a group of professionals that are very much into the details. And then the model code is adopted at a national level or a state level, and then modified or adopted on a local level. So Tunde, have you heard any? I have in my code purview at the local level and the state level. I haven't heard any COVID response regulations being developed to date. Have you heard anything on the national level that model codes are reacting to the COVID-19 pandemic?
No, not at this time. The only organization that took a position was ASHRAE, and they published on the website recommendations and operational, both as equipment improvement, but code authorities, they're quiet for now.
Okay. Next question. This is about marketing the building. Does it make sense to promote your HVAC systems if they are worthy? What message should you send to prospective tenants about the qualities of your system and how it's operated?
Thank you for the question.
Dan, do you want to take that one?
Yeah.
Dan, you're on mute, by the way.
Sorry about that. I'm not sure I've got the silver bullet for this question, but as Tunde and Ashwin were recommending earlier, and this is an exchange. It's a very sensitive issue. It's an exchange of information that really is required, I think, in any of these leasing negotiations. And I think to the extent you can, in your marketing materials, make prospective tenants comfortable with by providing that information about the upgrades to the system, the building systems, then why not? So I think there's a lot of space on the market, and virtually every major market on the planet at this point. And I think there's going to be a lot more coming online. So I think to help tenants to differentiate from buildings that they want to pursue versus those they know they don't, I think if you can float this type of very important information right to the top, make it easy for people to get comfortable with the environment that you're promoting.
Okay. A couple questions on increasing the amount of outside air into the system and the relative risk reduction. Tunde, could you give a sense of what sort of levels of improvement you might get if you went from the standard of 20-25% to say 100%? What kind of jump would you get in a gross way of risk reduction?
I can give example of the outside air percentage for a hospital that has return air system. Usually the hospital have at least minimum 50% to reduce the, to dilute and minimize the risk. So that means about double that normally is done now for offices. Most of the offices most of the hospitals that are designed right now and built have 100% outside air units with heat recovery. It is, since the SARS, actually, when we had in late 90s, the SARS epidemic, 100% outside air was recommended for hospitals and buildings that are high risk.
Okay. There's a question on how do you actually get the UV systems, if it's an induct UV sanitation system installed, how much do you actually have to slow the air down or increase the amount of lights to get the disinfected properties to be effective?
That's a good question. I haven't looked yet into how slow the air has to move. The air can be slowed down by enlarging the ductwork, and probably the slower the better. Currently, a normal velocity in a duct after the air handler is about 1,100 feet per minute. I think we are looking at going down to below 1,000 feet per minute to give more time for the air to pass through the light. I will have myself need to educate myself for these inline UV lights. In my 30 years career, I never installed one. I only installed in front of the coils, cooling coils, where they see a velocity about 500 feet per minute.
Okay. Question on filtering. Can an office building improve filtering of the air by keeping the fan on during occupancy times? Whether heating or cooling is needed, the fan stays on. And what should be the standard for the office building filters? The 0.3 microns at 80% capture rate, question mark, which I guess is the MERV 14.
Right.
So two questions there. So can keeping the fans running, whether the heat or cooling demand the airflow, would that improve the filtration rate? That's the first question.
Definitely, definitely. Normally air conditioners have to run even if you don't need to cool or heat because of the fresh air requirement inside the occupied rooms. So definitely if it is like a rooftop package unit, they can stop ventilating if the compressor doesn't run, but we would not recommend them. We would recommend for continuous airflow and filtration of the air for the space.
And then the follow-on question was, are MERV 14 filters then your recommended filter for central air systems?
Currently, yes, that's our recommendation.
Okay. And then there was a question about a sanitization system using hypochlorous acid in a fine mist in dental offices. Are you familiar with those systems, and what are the the benefits and risks.
I apologize. I am not familiar with that misting system. I would be reticent to recommend it because it would have particles of the chemical in the air, wouldn't be eliminated. I haven't encountered that type of equipment, so I cannot tell more than this.
Here's hopefully a quick question. What's the most cost-effective method to use, filters or UV systems?
I haven't put my eyes recently. I know that these calculations are made, but there is a trade-off, it's true, because filters take more energy to run the air through them than through the UV lights. UV lights consume electricity for them to be on. I don't have at the top of my head right now the comparison, which one wins, but definitely a professional engineer can provide you with a calculation and comparison.
Okay.
I would like to add to that, if we improve the filtration, the filter of the AHU, that might impact the sizing of the fan. So you might have to increase the size of the fan in some cases, depending on the size of the filter, depending on the type of filter you're planning to use. So on a capital cost, I think filters could be more expensive, but in a long-term point of view, UV could have a bigger impact on costs due to electrical use. Yeah.
Correct. For retrofits, definitely. Yeah, changing the fan, it has a big impact.
Question on the HEPA filters. Could you restate the specs on size of the particle and the efficiency for HEPA filters?
So HEPA filters come in quite a few grades, and their retention efficiency can vary from 99.998 to 99.598. So they vary depending on the size of the particle that you are looking for eliminating. They go down to a particle size of 0.001 microns, and ULPA is actually even more efficient than the HEPA. Correct me, Ashwin, if I'm wrong. We looked at the graph recently.
Yes, the ULPA filters are known to be they are known to be newer product, and they are slightly better in filtering efficiency.
Another filtering question. A question is, are MERV 14 filters significantly more restrictive to current code installed HVAC systems than MERV 13?
So currently, office buildings can go down to MERV 11, which is 60% efficiency, arrestance efficiency. So the MERV 14 is 95% efficiency, and those are required by code for hospitals. For office buildings, you are not required for more than MERV 11 or 60% efficiency.
Okay. And this is also a question on costs and most effective systems. Could you list the least costly measures to the most costly for air purification?
That's a good question. And so it depends if it's a new system or an existing system. Because if it is a new system, you can counter the pressure drop by enlarging the filter section size. It is becoming, it's more expensive to buy MERV 14 filter than a MERV 11. But operational, you can achieve same operation costs for MERV 14 like for MERV 11 if you design for that purpose. Which mitigation are the most inexpensive? Would be filters if the existing air handlers are capable of taking new filters, or if it's a new air handler, filters will be, I think, the most cost effective.
Okay, and this one is get your calculators out. And if you set your outside air to say 20 to 30%, how many hours approximately does it take to get to replace 100% of the air in an average normal office HVAC application?
So this depends on the rate of the air supplied into the room. So let's say a room is ventilated at 6 air change rate, but an office normally it's more around 4 air change rate. So that means in 1 air change you get 25%. So in 1 hour you get 25% of the air, if I'm correct. Ashwin, correct me if I'm wrong.
Yeah, correct. Yeah, it's low. So when it comes to 20 to 30%, so let's take, for example, we have 100, we use the unit cubic feet per minute when we talk about air rates applying to a space. So let's say we have 100 CFM, that's the total supply to a space, and 30 CFM is the fresh air. So since the units are in minutes, that'll take about 3 to 4 minutes for a complete change in the amount of air in the space.
No, it's not CFM, but it's air change per hour. I have to disagree on what you're saying, but CFM per minute, it's just giving you 25 CFM in a minute, but to change through the entire space, the fresh air, well, yeah. I think I muddled myself.
Yeah. Well, once again, you have your contact information, so you can email and you guys can run the calculations offline. Let's see here. There was a follow-on question to naturally ventilated offices. So if you have an older building that doesn't have an HVAC system and has operable windows, what would be the recommendations you would make for an office that has that type of system, say in some of the older buildings in San Francisco and other cities?
I would recommend to put, there is so-called mechanical mixed ventilation mode. So we have operable windows and openings in the building, but to increase the air change in the space, we would put on the roof or somewhere an exhaust fan to try to bring in more fresh air than naturally would come in due to temperature difference or wind pressure on the building. So at a minimum, we would recommend to have an exhaust fan that would increase the air changes into the space.
Okay, very good. There's another question here about distance and travel. It's quite technical. I will pass that along to you privately and you can answer it. All right, I think that kind of covers most of the questions. I wanted to sort of reiterate that this is about welcoming tenants back into the building. And this is about tenants welcoming their employees back and allowing all of the parties to make their own risk assessments. So it's about transparency, as we said earlier on in our presentation. It's about transparency, about information, about how the systems are designed and operated, and sharing that information in a transparent way so that all people are aware of what their risks are and they can make their own judgment. So I wanted to thank Tunde and Ashwin and Dan in particular for setting this up. And we welcome everyone back for other seminars on gridding.
Wonderful, wonderful. Thank you. Thank you to everybody. I'd love to end this on a happy note. I guess the happy note is that Grittig is going to be hosting additional webinars, and it's wonderful to have such talented and well educated and experienced people available to address the community. So that's a big part of what Grittig is trying to do. It's a lot of ounce of prevention. And that's quite an understatement for what we're all trying to deal with in this pandemic. No one has said, but it certainly is possible there'll be some epidemic or pandemic down the road. I think all of this preparation and upgrading of building systems is only going to help. But I think the underlying conclusion here is that this is definitely a risk issue. Science is quite reliable. Science is not perfect on this topic just yet. Otherwise, we'd sort of be through it or a lot closer to seeing the end of it. But I'm at least for our office leasing clients, we're leaning toward being very conservative and cautious. And if it isn't safe to get in an elevator, and Tunde, if you've got to walk up, 30 or 40 flights of stairs, you're going to be in great shape, folks. Anyway, so again, thank you to everybody for coming. Tunde or Ashwin, if you could paste the link to your deck in the chat area, yeah. And make sure you send that to me also, because if there are folks that are looking for that and approach me separately, I want to make sure that I can make it available to everybody. So thank you so much, everybody. We're going to close and just say stay well, stay safe, and we'll look forward to seeing you again soon. Take care.
Thank you, Dan.
Take care.
Thank you.